Hi, hello, good day students. Today, we are going to study all about prime factorization. But before we get into the meaning of prime factorization, let me give you the two key ideas that will help us understand prime factorization. The first one is factors. Factors are the numbers that we multiply to get another number or the product. Here in my example, as I show you, 4 times 5 is equal to 20. The two numbers that you multiply to get 20 are called factors. So 4 and 5 are one of the factors of 20. Next word, let's have prime numbers. Prime numbers, or the prime number, has exactly two distinct factors, which are 1 and the number itself. So when a number has only two distinct factors, they are prime numbers. But if the number has three or more factors, they belong to composite number. So these are the first or the prime numbers that are less than 20. So we have here 2, 3, 5, 7, 11, 13, 17, and 19. So we have more prime numbers bigger than this number. So these are just prime numbers that are less than 20, which are we usually use. Okay, so with that, let us define prime factorization. What is a prime factorization? A composite number can be expressed as a product of its prime factors, and this process is called prime factorization. In other words, prime factorization is expressing a composite number as a product of its prime factors. Okay? So we have two methods in finding the prime factorization of a number. First, we have the factor tree. It is done by breaking or branching or splitting the number into any factors until you reach all the prime factors. The other one is a continuous division. It is done by placing the number in upside-down division bar and dividing it with a prime number. So, to understand clearly these two methods, let's try to use each of them. Let's start from a factor tree method. So, let's find the prime factors of 18. So we are going to split 18 into its factors. So you can start from any factors or from any pair of factors. In my example, I split 18 into 3 times 6. Because when you multiply 3 and 6, the answer is 18. So I split it down into 3 times 6. Then, you have to check or to identify each of the factor if it is a prime or not. If it is a prime, encircle that number. It means we're done with that number. If the other number is not a prime, then you have to continue breaking it into its factors. So let's start from 3. Is 3 a prime number? Yes. So we will encircle it. It means we're done with number 3. We can no longer split it down or split it because 3 is already a prime number. In our goal, we have to find the prime factors or the prime numbers that when you multiply, the answer is 18. Then, let's have 6. Since 6 is not a prime number, we will continue finding its factors or branching it out into its factors. And we get 3 times 2 or 2 times 3. Then, identify each of the number. 3 and 2 are prime numbers. So, encircle 3 and 2. It means we're done with 3 and 2. As you can see, all the number that are left are all prime numbers. So, the encircled one are 3, 3, and 2. Therefore, the prime factorization or the prime factors of 18 is 3 times 3 times 2. To check if your prime factors were correct, just multiply them. 3 times 3 is 9, times 2 is 18. Okay, let's have more example. Let's try to get the prime factorization of 24. So again, you just have to split it into its factors until all the remaining factors are all prime. So we can have 12 times 2. Even if you use 8 times 3 or 6 times 4, still you will come up with the same number of prime factors. Okay? So let's check each of the number. 12 is not a prime, so we cannot encircle it. And 2 is a prime, so encircle it to indicate that we're done with that number. Since 12 is not a prime number, we will continue splitting this number. And we can have 4 times 3. Okay, then same process. Identify if each number is a prime or not. 4 is not a prime, so we will continue splitting 4. And since 3 is a prime, we can encircle it already. Okay, so we have 4. Think of a number that when you multiply, the answer is 4. Very good. We only have 2 and 2. So here in this method, children, you cannot use the 1 and the number itself, because the process will continue or will not stop if you keep on using the 1 and the number itself. Okay? So we have 2 times 2 is 4. Since 2 is a prime number, we can encircle both. Okay? So as you can see, all the remaining numbers are prime numbers. So therefore, the prime factorization of 24 is 3 times 2 times 2 times 2. Don't forget to check if your prime factors are correct. Multiply them. The result should be the number that we factor out, or the composite number. 3 times 2 is 6, times 2 is 12, times 2 is 24. It means our answer is correct. Okay, so let's have more example. Let's have 40. Split it into its factors. So we have 10 and 4. Since 10 and 4 are not prime factors or prime numbers, we have to split it down. 10 can be branched out or can be broken into 5 and 2. Since 5 and 2 are prime factors, you can encircle them. It means we're done with those numbers. And then we have 4, which can be split into 2 and 2. Since 2 is a prime factor or a prime number, encircle them. Okay. So, we got 5 times 2 times 2 times 2. So, those are the prime factorization of 40. Check. 5 times 2 is 10, times 2 is 20, times 2 is 40. Last, we have 27. So, split the number into its factors. We can have 9 times 3 or 3 times 9. That's still correct. Then, identify the prime factors or identify if the numbers are prime or not. 9 is not a prime number, so we will keep on getting its factors or splitting it into its factors. Since 3 is a prime number, so we can encircle it. Then, let's have 9. Think of a number that when you multiply, the answer is 9. So we have 3 and 3. Check 3 if it is a prime. Of course it is. So you can encircle it. Okay, since we have no more numbers to split out, we're done. So therefore, the prime factorization of 27 is 3 times 3 times 3. So that is using factor tree method. Okay, just a trivia. It's like it is called factor tree because as you can see, you can create like a Christmas tree as you split the number into its factors. Okay, let's try using the other method, which is continuous. Okay, let's have the continuous division method. So let's use the same number earlier we have in a factor tree method. Let's find out if we will get the same answer. So 18. In continuous division method, we divide a number with a prime number and we do it in using the upside down division bar. Okay? So think of a prime number that can divide 18 without any remainder. Very good. You could have 2. Then divide 18 divided by 2 is 9. So the quotient should be written under 18 or the division bar. Since 9 is not a prime number, we will keep on dividing it until we come up or the last number at the bottom is already a prime number. Okay, so don't forget to write another upside down division bar. Think of a number that can divide 9 without any remainder. Okay, so we have 3. Then divide 9 divided by 3 is 3. And since 3 at the bottom is already a prime number, it means the division ends there. And so the numbers outside the division bar are the prime factors of 18. Therefore, the prime factorization of 18 is 3 times 3 times 2. And if you can still remember, we have the same answer using the factor tree method earlier. Okay, let's have 2 more examples. Okay, next number we have 24. Again, we use the upside down division bar. Then think of a prime number that can divide 24 without any remainder. Okay, so we have 3. So you can start with any prime number as long as it divide the given number without any remainder. So here we use 3. 24 divided by 3 is 8. Write it below the original number. Then the process will repeat. Think of a prime number that can divide 8 without any remainder. Very good. We have 2. 8 divided by 2 is 4. Write 4 below 8. Then don't forget to draw a division bar. Then think of a prime number that can divide 4 equally. Okay, we got 2. 4 divided by 2 is 2. Write it below 4. Since 2 is already a prime number, we could stop dividing 2. Okay? So, collect the numbers outside the division bar. We got 3, 2, 2, 2. Therefore, the prime factorization of 24 is 3 times 3 times 2 times 2 times 2. Check it. 3 times 2 is 6, times 2 is 12, times 2 is 24. Okay, let's have the last one. 36. Don't forget to draw the division bar. Then think of a prime number that can divide 36 equally. We got 2. 36 divided by 2 is 18. Write it below 36 and then write or draw another division. I mean upside down division bar. Then repeat the process. Think of a prime number again that can divide 18 equally. We have 2. Then 18 divided by 2 is 9. Write it down. 18. Since 9 is not a prime number, so we will keep on dividing it. Think of a prime number that can divide 9 equally. Of course, we got 3. 9 divided by 3 is 3. Since 3 is already a prime number, the process stopped there. Okay? So, therefore, the prime factorization of 36 is 3 times 3 times 2 times 2. Okay, that is how we do continuous division method. That's all about prime factorization using factor T and continuous division. So, you can use your preferred method in getting the prime factorization of a number. Okay, so you can choose the easier method for you. Okay, don't forget to remember a composite number can be expressed as a product of its prime factors. This process is called prime factorization. To obtain the prime factorization of a number, you can use factor T or perform continuous division. Okay, so that's all for this video.